Let's continue on with section 7.3, and where we are looking at the tabular integration method. And tabular integration method will work really, really well if I have a polynomial that will eventually, if I take its derivative, will eventually go to zero. And so polynomials are a style that will do that. So typically you're going to find that this function goes to zero and it will be an algebraic type function. The other thing that I need to have happen is if I have my other function, let's call it g of x, if I can integrate g of x easily. So I need to be able to integrate the one and take the derivative of the other. The derivative eventually has to go to zero. And once I do that, then I draw in some slanted lines and I alternate positive, negative on that. You'll see how this works in a moment. Let's do x squared e to the x integral of this, which we did earlier in notes, and we had to do a couple integration by parts steps to do this. So I'm going to select my u to be x squared. And I need to take its derivative. So if I take its derivative, I'm going to get x squared, 2x, 2, and 0. So this was nice because it zeroes out. My other function, g of x, this is my u. This acts as my dv. And I'm going to integrate the dv. So I'm going to start off with e to the x. I'm going to integrate it. I get e to the x. I'm going to integrate it. I get e to the x. I'm going to integrate it, and I get e to the x. I'm going to make my right-hand column equal to the left-hand column as far as number of terms that I did. The third step is to now draw slanted arrows and put alternating signs above them, starting with a positive. So I'm going to draw in a slanted line. I'm going to connect the first term with the second term, the second term with the third term with the fourth, and then I'm done once I hit 0. This will be a positive, this will be a negative, this will be a positive, because I start with the positive and alternating. Now this creates the answer, and the answer is formed by the product of the diagonal. So I'd have an x squared e to the x that's positive minus 2x e to the x, and then I add, make this positive, 2 e to the x plus c, and I'm done. This tabular method is wonderful, easy to do. Let's try another. Do I have a function that its derivative will eventually go to 0? Yes. This will eventually zero out, so it's algebraic. The other function is really easy to take the integral of. So I've got two functions, f and g. When I first started teaching this, I did that. I think of more of u and dv, to be honest, because it's integration by parts. It's just tabular method, which shortcuts it. So let's get our u down, x squared minus 5x, take its derivative, 2x minus 5, take its derivative, 2, take its derivative, 0. Now I need to go over on the right-hand side and find the integrals. Write down your first function. So we always have that starter value that comes directly from your integral. Now, we got to integrate. The integral of sine is negative cosine x. The integral of negative cosine is negative sine x. The integral of negative sine is positive cosine x. And I do it until I am equal with the 0. So I need to do it as many times as I end up taking derivatives. That's how many times I've got to take integrals. Now we're going to do our diagonal line, first term to the second, and so on. It'll be a positive, negative, positive. I always start with positive. And now it's the products of the diagonals. So I'm going to have a positive times a negative will still be negative x squared minus 5x times the cosine of x. My next one will be minus minus, so I'll have minus negative sine x. I'm going to take the order a little differently here. 2x minus 5. Obviously, that's going to become plus. And then my last one's going to be positive. Everything's positive, so it's going to be positive 2 cosine of x plus c. Super easy. Really nice. That is the answer. If I'd had, a third, then I would just have a little bit longer columns. If I'd had x to the 3, that would have required 3 separate integration by parts. So I think you'll see and agree that tabular method is way faster and way more fun. So we are working on some homework here, and we'll talk about that. I'll post that in Schoology because I got to look at that to see if some of these later problems involve tabular method. Okay, see you later.